Let's start with group one. Group one may present their answers. Yeah. Please
Okay, sir.
turn on your video and so that all of you, all the group's member. Wait. Who else besides Darren? Why only Darren? Gracia and Alisa. Yeah, you may start.
Okay, good morning, Saudari and friend. Today we are going to present our answer. This is the question, so we need to find the V output here using nodal analysis.
Okay, so first what we do is we use nodal analysis for V1 when V1 is over here. So on the left side, we can see that V1 minus 12 angle 30 divided by the resistor, which is 2 ohm. And then after that, we add V1 divided by 1, and then V1 divided by J2, and then V1 minus V node divided by negative J1. And then after that, we multiply the whole equation with J2, and then we cross out anything that is not needed. After that, we change the negative 12 angle 30 to complex form. And then we make it into numbers. And then after that, we simplify it. And then the result is this, the bottom part.
Okay, so next is we find the V from the V output node. And we will get the equation like this. V1, V output divided by 1, add with V output minus V1 divided by minus J1. And then we will multiply it with J1 and we will get this equation and we will simplify it to get the V1. And then we will substitute the V1 to the equation before here. And we will get this.
Okay, so after substituting, we can add out all the like terms together. And what we will get is 4 V naught plus J 4 V naught equals to negative 6 plus J 6 root 3. And so we can just make the V naught alone. So we can get negative J plus J 6 root 3 divided by 4 plus J 4. And because this is division, so we prefer to use phasor. So we change everything to phasor. So 12 angle negative 60 divided by 4 root 2 angle 45. And because it is negative, so we can add 180 degrees. So 12 angle 180 minus 60, which is 120 degrees, divided by 4 root 2 angle 45. And basically we will get 2.12 angle 75 degrees.
Okay, well done, group one. Thank you for the concise answer. Let's proceed with group two. Okay, group two. Please turn on your camera. Group two is Catherine and Elisa and Elijah. Where is Catherine? Okay, you may share your screen. Where is Elisa? Only Mars.
Sorry, sir.
The surface of Mars.
Just connected my webcam.
Oh,
Okay.
okay. You went to Mars.
Yes. What? Okay.
Yes, we cannot see yet your screen. It just shows has started screen sharing. Catherine Kimberly has started screen sharing, but cannot be seen.
No.
Catherine, internet is not very good, sir, I think.
Okay, now we can see.
Ini berarti persediaan awal tambah beban
Cat, ini belum
kan
siap
dikurangi
tadi.
persediaan akhir loh.
Great.
Sama dengan HPP ya kan. Jadi nanti ya tinggal betul gitu. Ini kan? Ini kan? Wow.
Okay. So this is the question for number 2.
Yes.
Find E1 using nodal analysis. Yeah. I make node V1 and node V2 in here. And then we using KCL in V1 and we get this equation. And then for the V, this is
Tadi belum masuk kayaknya.
Ya? Oh ya.
Kalau nggak buka itunya
Iya,
aja. Cam scan-nya aja.
Gimana ya? Oh, sorry.
So you calculated until V1, then?
No, sir.
Masukin.
Wait, aku aja. Can you guys see my screen?
Not yet, Elias. Yeah, okay, now we can see.
Okay. Wait, okay, so lanjut Cat.
Yeah, this is the node analysis KCL for node V2. And then we turun ke bawah gitu. And we get the V2 is equal to this equation, and we substitute V2 back in the equation 1 on KCL V1, and turunin lagi.
Turunin lagi.
Yes. Yeah, we get V1 is equal to 10 point Phasor 12.138 degree.
After we got this V1, we could basically find the I1 using this equation. Then we input the V1 that we gathered before into the equation, and then we find that the I1 for the circuit is 0.778, and this. Okay.
Okay, how come yeah, explain to me from 10.5, the I1, oh, yeah, there, I1, okay, divided by 3 plus J2, okay, then how you get into the 0.778, angle minus 161.84?
For the angle, we add 180 degrees. So it's actually same, sir.
Yeah, but you didn't do conversion from phasor to complex to phasor. How did you calculate it? The process.
I think we just forgot to put the forgot to put it, sir, because we did it, but we forgot.
Okay, so next time please put it there later in your uploaded answer. Please put the process as well, yeah, not just after like this. Then how come? So because if you divide division, then usually you have to convert first the rectangular complex number into phasor format, right?
Yes,
On the other hand, the upper part, the numerator part, you have to, since it is subtraction, right? you have to convert first into rectangular complex format, do the subtraction, and then reconvert again into phasor format. Okay, and I want to know that process.
Yes, sir.
Okay, thank you, group 2.
Thank you, sir.
Thank you, sir.
So let's welcome group 3. Group 3 is double D, yeah? Dimas and Dave.
Yes, sir.
Double D. Okay,
Coincidence.
you may. Yes.
It can be. Dimas?
So the question for number 3 is to find the Vx or using nodal and loop analysis. First, we mark the V1, V2, V3, and V4. Then we choose V3 and V2 as the supernode. Then we write the ACL for the supernode V1 and V4. From the supernode, this is the constraint of V3 and V2. Then we substitute di apa namanya di hasilnya. We substitute V3 and V2 to the KCL equation.
Okay. Yeah. And then we simplify. And then we actually just put the V3 and V1 in here. So we get, I'm confused. Oh yeah. We get this, and then we insert the V1, which is the tenfold, and also the V3 here. Yeah, I'll explain later. And then we get this. So it is expressed in V2 and also V4. I actually do the wrong step here. Actually, it is better to use V2 equal to V3. So it is V3 and V4. So that when we do KCL at node 4, V4, this here there is only V4, V3, and V1, and we already know the V1, so we can directly use elimination. We can directly use elimination in terms of V4 and V3. Yeah, we can do elimination in terms of V3 and V4, and then we eliminate V3, and then we got V4 directly, where V4 is actually equal to Vx. And then we are not finished yet, sir.
Oh, you haven't finished?
Yes.
Yeah. Okay, so a bit of low mark then for the presentation. Okay, thank you, group 3. Please finish it, yeah, so that you can upload the finished solution in mesh and node analysis, yeah, using nodal and mesh analysis. Thank you, group 3.
Thank you, sir.
Let's move further to group 4. Group 4 is, who is group 4? Martin, ya? Nikki, ya?
Me and Michelle.
Nikki and Michelle. Nikki and Michelle. Okay, please, you may start your presentation anytime.
Hello.
Yes. Yes.
So this is we use mesh analysis. So from this circuit, we know that I2 minus I1 is equals to 90 degree ampere, and then we wrote it like this. And then for the mesh analysis, minus 24 with 0 degree plus 2I1 minus G2I2 plus 2 I2 is equals to 0. And then we substitute this with this, and then we got this equation. And then through a series of calculation, yeah, and then we got I2 is equals to 5.44 with 36.03 degree M. And for the V0 is equals to 2 times I2, where I2 is 5.44 with 36.03 degree amps. And then we got 10.88 with 36.03 degree. And then next part is Nikki. Wait. Okay, this one. Yeah, kan ya?
Okay, next for the method using Thevenin's theorem. First, we open circuited the circuit. We find VOC first. VOC consists of this voltage source and 2 ohm. We calculate it. Negative VOC is equal to 2 times the current, which is 2 with 90 degree. And then we got VOC is equal to J4 plus 24. And then we change it to a phasor form by using 24 square plus 4 square is equal to 24.33. And then 9.462 degree is the arctan theta. The arctan theta of 4 over 24. And then we calculate the Thevenin's resistance by short circuiting the voltage source and open circuit the current source. And then we will get the Thevenin resistance equal to this one. And then we make the Thevenin equivalent circuit as shown in this figure. And then we find V0 by using the voltage divider, 2 over 4 minus J2 times the Thevenin voltage. And then we will get the answer.
What is the answer?
10.88 with a degree of 36.03 degree. For degree, if division, it will turn into minus. So 9 blah 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 minus 26 blah blah. Minus negative 26 blah blah blah.
No unit?
Voltage.
Reduction of mark.
Sorry, sir.
Yeah, it could be volt, it could be ampere, it could be joule. You have to put the correct name. What is, see the first page? I want to see the first page. Using mesh analysis. Do you have unit? No unit also. Michelle. Okay, thank you. Yeah. Please correct it in your uploaded answer. Do not forget the unit. Yeah. Okay, that will cause, if you forgot the unit, causing you reduction in mark. Thank you, group 4.
Thank you, sir.
Let's proceed further to group 5. Group 5 is Osama and Martin. Where is Osama?
Where is Osama? Osama.
Yes, hello, sir.
Okay, hello. Okay, please proceed.
Okay, so first, this is the question. And what we are looking for is the V0, the one in the capacitor. So we can solve the circuit using mesh analysis. So we have 3 mesh, loop 1, loop 2, loop 3. And then we can just go around the loops. So 4 ohm times I1, then J4 times I1 minus I2, J2, I1 minus I3, and so on and so on. And then we can rearrange them so we get I1, I2, and I3. And then we do the same thing with the second loop and the third loop, and then we can make them into matrix.
Okay.
Okay. After putting in the matrix, we can use the Octave solver or MATLAB solver to get the currents, which is I1 and I2 and I3. And because of VO is in the second loop, so we are just looking for I2. And yeah,
Here,
and
V0 here equal J2 times I2.
Yeah.
exactly. So
Can you express it as phasor?
Or as phasor,
Yeah.
then it will go to the down right. Where is it?
Down right. Where is it? Down right is only white color. It's empty. Wait.
I haven't do that, sir.
Do it now. Do it now quickly. What is in phasor?
How? Annotate.
Yeah, annotate or whatever. You can use annotate. So first, yeah, find the magnitude. Yeah, just calculate the magnitude and the phase angle. Yeah, 1 point. Okay.
Calculator.
Negative 12.34.
34.
Okay, good. Correct. Thank you, group 5. Well done. Let's move on to group 6. Last but not least, group 6, Jesse and Hanif.
Okay, hold on. Wait, where is it?
Please turn on the videos.
Okay. Oh.
Can you please enlarge the... Yes, so we can read it better. Yes, you may start explaining your answer.
Okay. So in question number 6, we are going to find I1 using the superposition. So first we have to find the equivalent impedance from the 3 different perspectives of the 3 different sources. First here, we're going to calculate from the 12 with the phasor of 0 angle volt. And so there were some series elements that we combined and some parallels. And in the end, we got I1 from the 12 phasor 0 volt is minus 1.76 with a phasor of minus 41 angle ampere degrees. Yeah. And
yeah, this somehow doesn't seem to be correct.
What is it?
Yeah, your answer is not correct somehow.
Oh, there's some miscalculations there. Sorry, sir.
Miscalculation, or is it not complete yet? The calculation. You already incorporate all the contribution from the 3 different sources.
No, that's just
yet,
from
sir.
the one, sir.
Oh, from the one.
That
Okay,
was,
okay,
yeah,
okay.
just from
Yeah.
the voltage.
Okay.
From the 12 volt. So this is from the 6.
Please enlarge it. I cannot read.
Okay, sorry.
Sorry, sir.
I'm not as young as you.
This is from the 6 with the phasor of 0 angle volt source. Here, it's similar method with the previous one. So we parallel and series some elements, and the result for this from this perspective is 1 with 1.5 with the phasor of minus 55 angle degrees.
Okay, and finally the last contribution from the current source.
Yeah.
All right. And finally, due to the contribution of current source, we have the yep, we have the current source here. It is 3 ampere with a phase angle of 10 degree, and we're gonna have a simple calculation using current division. So firstly, we have to calculate the current that goes through here. That means we're gonna minus J2 over 4. Yeah, I guess. Wait, I think this is a mistake. Oh yeah, 4 minus J2. So yeah, and times the current that goes into this node. We have the I2 equals 1.35 with a phase angle of minus 53 degrees. And then we do current division again to find the current that goes, that flow in this node. And then J3 over 3 plus J2 times I2, because previously we have calculated the I2. And then we found that the I1 double dash equals to 1.12 with a phase angle of 3 degrees ampere. And then we add 3 currents from 3 different contributions, from I1 and I1 dash and plus I1 double dash. So minus 76 with a phase angle of minus 41 plus this and plus this. It should be the value of I1, but we haven't calculated because it is
Now
modeled in
it's
the
quick,
form
and
of
you can calculate quickly.
yeah.
We need to. Can we from the phase apa bilangnya nih? From the
From
phaser can we
you
do
convert
addition?
each one you convert first to rectangular complex number.
Yeah.
Then you have the result in rectangular complex number. After that, you can reconvert back to phasor form.
Yes.
So this is not yet finished then.
Yeah, just the final value.
A pity.
Almost, sir. It's almost.
Okay, please complete for uploading the final answer to the
yes, sir.
Google Classroom. Please do not forget the unit properly. So incomplete answer is cause some reduction in the presentation mark. Okay, thank you, Jesse and Hanif.
Thank you, sir.
Okay, thank you, sir.
So that will be all for today, students. So please do not forget to fill in the online attendance for the third hour, week 10, session 3. The OTP is 4521.